Accepting you put Betelgeuse where the Sun is, it would grow to the orbit of Jupiter, turning into a monstrous, unstable giant, nearly on the verge of explosion. Betelgeuse is quite possibly one of the most observable stars in the universe, radiating more energy than a billion suns. Known as a red giant star, it is so enormous that if placed in the Sun's position, it would extend to the orbit of Jupiter, an immense, irregular object ready to explode. When we consider stars, we commonly envision small, twinkling lights in the night sky, as seen from Earth. However, stars are far more complex. One of the most fascinating stars, Betelgeuse, is much larger and more intriguing than our own Sunday. Betelgeuse has puzzled astronomers for decades, and recent advancements, particularly from the James Webb Space Telescope, have revealed even more startling information. The star's unpredictable behavior has left scientists increasingly concerned. In this discussion, we explore the remarkable new findings about Betelgeuse, its imminent destruction, and the impact this will have on the universe and life on Earth, as explained by physicist Michio Kaku. The mystery of Betelgeuse. Betelgeuse is a massive marvel, a giant star that has captivated astronomers for centuries. The Greek astronomer Antonius first documented it. It is so enormous that it can be seen from Earth, especially during the winter months. If you're interested in astronomy, you've probably heard of or seen this star. It marks the upper left shoulder of the Orion constellation. Betelgeuse is an aging star and one of the brightest stars in the night sky. However, its brightness is far from stable. It fluctuates, making this variability one of the star's defining characteristics. This change in brightness is something that warrants further investigation. Most of the stars we see are incredibly far from Earth, with the closest star, other than the Sun, being Proxima Centauri, about 4.2 light-years away. To understand light-years, imagine traveling at the speed of light, 186,000 miles per second or 299,792 kilometers per second, for an entire year. This covers billions of miles. So, when we say a star is 4.2 light-years away, we're talking about a distance of trillions of miles. Betelgeuse, however, is much farther, about 600 light-years away. Even at the speed of light, it would take 600 years to reach it, a time frame far beyond our current technological capabilities. Despite this immense distance, Betelgeuse shines incredibly brightly in our sky. Its massive size is the reason it remains so visible. It is estimated to be 10 to 20 times more massive than the Sun, with a radius hundreds of times larger. When viewed through telescopes, it appears as a disk rather than a tiny point of light, unlike most other stars. This is likely due to the turbulent reactions occurring in its outer layers. Betelgeuse's unstable nature. Regarding its mass, Betelgeuse is estimated to be between 12 and 19 solar masses. A solar mass is the standard unit used to measure the mass of stars, with one solar mass being roughly 2 times 10 superscript 3 kg, the mass of our Sun. Since Betelgeuse lacks companion stars or orbiting planets, scientists cannot determine its exact mass, but it is undeniably much heavier than our Sun. Another key characteristic of Betelgeuse is its luminosity. Its brightness fluctuates between magnitude 0 and plus 1.6, with magnitude 0 being 2.5 times brighter than magnitude plus 1. At its peak brightness, Betelgeuse can be thousands of times more luminous than the Sun. This variability in brightness is due to its pulsations. Betelgeuse expands and contracts. When it expands, it becomes brighter. When it contracts, it dims. These pulsations can last anywhere from 10 to 100 days, contributing to its dynamic appearance in the night sky. A remarkable feature of Betelgeuse is that its surface is covered in dark magnetic spots. These spots are regions where the magnetic field is stronger than the surrounding areas, interfering with the flow of hot gas to the star's outer layers, making these regions cooler. This explains why Betelgeuse is cooler than our Sun despite its immense size and brightness. The spots on Betelgeuse are significantly larger and more numerous than sunspots on the Sun. In fact, some of these spots can be twice the size of Earth. Betelgeuse also has a magnetic field many times stronger than the Sun's, causing the gases in its outer layers to twist and swirl. When observed through telescopes, Betelgeuse has a surface temperature of about 3,500 K, 3,227 degrees Celsius, or 5,840 degrees Fahrenheit, which contributes to its weak red color. However, Betelgeuse wasn't always a red star. About 10 million years ago, it was yellowish, much like our sun. Over time, it began changing color, shifting from orange to red. This gradual color shift suggests that Betelgeuse is evolving. The future of Betelgeuse, a supernova in the making. Despite its massive size, Betelgeuse is not the largest known star. Its estimated mass ranges from 12 to 20 times that of the Sun, and even at the lower end, it remains an enormous celestial body. The fluctuations in Betelgeuse's brightness and dynamic nature result from its ongoing pulsations. These pulsations, driven by internal cycles, cause the star to expand and contract, altering its luminosity. When Betelgeuse expands, it brightens. When it contracts, it dims. This variability makes Betelgeuse one of the most dramatic and unpredictable stars in the night sky. As a red giant, Betelgeuse is nearing the end of its life. It has exhausted the hydrogen fuel in its core and is now fusing heavier elements like helium and carbon. This fusion process generates energy, causing the star to expand. Its atmosphere is filled with complex physical phenomena, including dark magnetic spots that disrupt heat convection, leading to cooler regions on its surface. Eventually, Betelgeuse will meet a dramatic and spectacular end. When it runs out of fuel, it will undergo a catastrophic collapse, fusing even heavier elements like carbon and oxygen. This process will cause Betelgeuse to expand even further, becoming one of the largest stars in the sky. In the end, Betelgeuse will die in a massive explosion known as a supernova. The intensity of this explosion will be so powerful that it could outshine an entire galaxy for weeks, sending shock waves through space. While this event is inevitable, scientists are closely monitoring Betelgeuse's behavior as it approaches the final stages of its life. The star is expected to go supernova within the next 100,000 years, a brief moment in the grand timeline of the universe, yet still too distant for us to predict with absolute precision. The James Webb Space Telescope, JWST, has provided new insights into Betelgeuse's behavior. The telescope's infrared capabilities allow scientists to study the star's outer layers and magnetic fields in unprecedented detail. These findings confirm Betelgeuse's ongoing changes, including its irregular brightness and potential instability. When Betelgeuse explodes, the supernova will release enormous amounts of energy, creating heavy elements like iron and nickel, which are crucial for forming planets and other celestial bodies. These elements will be scattered across the cosmos, enriching the interstellar medium and contributing to the birth of new stars and planets. In a broader sense, Betelgeuse's death will not only mark the end of one of the largest visible stars, but also pave the way for the formation of new celestial objects. Though we won't be around to witness Betelgeuse's final moments, when Betelgeuse eventually goes supernova, it will be one of the most spectacular celestial events in human history. If it happens within our lifetime, the explosion will be so bright that it could outshine the full moon for weeks, possibly even being visible during the daytime. This would provide astronomers with a rare, up-close view of a supernova event, allowing them to study the physics of star deaths in real time. After the explosion, what remains of Betelgeuse depends on its final mass. If the remnant core is between 1.4 and 3 solar masses, it will collapse into a neutron star, a city-sized, incredibly dense object with gravity, so strong that a sugar cube-sized piece of it would weigh billions of tons on Earth. If the core exceeds 3 solar masses, the collapse will continue beyond a neutron star, forming a black hole, a region of space where gravity is so intense that not even light can escape. Given current estimates, Betelgeuse's fate is uncertain, but both possibilities are equally fascinating. Will Betelgeuse's supernovae affect Earth? A common question is whether Betelgeuse's explosion will impact Earth. Fortunately, at 600 light-years away, we are at a safe distance. While the supernova will emit high-energy radiation, including gamma rays and X-rays, our atmosphere and magnetic field will protect us from any harmful effects. However, the event will still be significant for astronomy. It will 1. Enrich the interstellar medium. The explosion will scatter heavy elements like iron, nickel, and oxygen into space, contributing to the formation of new stars, planets, and potentially even life. 2. Trigger new star formation. The shock waves from the supernova could compress nearby gas clouds, leading to the birth of new stars. 3. Provide a learning opportunity. Studying a nearby supernova in real time will give scientists invaluable data on the life cycle of massive stars. The significance of Betelgeuse in astronomy. For centuries, Betelgeuse has played a key role in our understanding of stellar evolution. It has helped scientists refine models of how stars live and die, and has been a prime candidate for studying pulsations and magnetic fields in red supergiants. With modern telescopes like the James Webb Space Telescope (JWST) and future projects like the Extremely Large Telescope (YELT), astronomers will continue to monitor Betelgeuse's behavior, looking for further signs of its impending collapse. A cosmic reminder. The eventual death of Betelgeuse is a reminder of the constant change in the universe. Stars are not eternal. They are born, they evolve, and they die, sometimes in spectacular fashion. But even in death, they leave behind elements that become part of new stars, planets, and even life itself. When Betelgeuse finally explodes, it won't be an end, but rather a beginning, a contribution to the next generation of cosmic structures. Whether it becomes a neutron star or a black hole, its legacy will endure, just as past supernovae contributed to the formation of our own solar system. For now, we continue to watch, wait, and learn, knowing that somewhere in the vastness of space, one of the greatest celestial fireworks in history is slowly approaching. Offers a brief look into the destiny of other stars with comparative qualities. As innovation propels, researchers desire to study Betelgeuse with cutting-edge devices and space observatories. The information accumulated from Betelgeuse will shape our comprehension of cosmology, helping us unlock the secrets of heavenly development and the forces at work in space. Betelgeuse, as a huge and dynamic star, is a vital piece of the astronomical riddle. Its inevitable end will be one of the most captivating events in the historical backdrop of the universe. While Betelgeuse's demise is inescapable, it's essential to remember that the universe is continually changing. New stars are being born consistently, and the energy delivered by supernovae like Betelgeuse's will ensure that the cycle of life and death continues. The legacy of Betelgeuse will live on, not just in the elements it creates, but also in the knowledge it has provided to generations of astronomers. By studying stars like Betelgeuse, we can continue to unravel the mysteries of our universe, gaining deeper insights into the forces that shape space and our place within it. Through these vast giants, we are reminded of the vastness and complexity of space and the astounding processes that govern the universe we call home. Betelgeuse, one of the most well-known stars in the universe, has been a subject of intense study by astronomers for centuries. Its eccentric behavior and enormous size make it a fascinating object for research. Beyond its size and brightness, Betelgeuse plays a fundamental role in understanding the life cycles of stars, especially those nearing the end of their existence. Like other massive stars, Betelgeuse has depleted the hydrogen in its core and is transitioning to fusing heavier elements. As this process unfolds, it significantly alters the structure and characteristics of the star. The ongoing changes in Betelgeuse's brightness and color reflect the complex processes occurring within the star as it reaches the final stages of its evolution. The end of a massive star like Betelgeuse does not happen suddenly. Over time, the star will expand to colossal proportions, ejecting its outer layers into space. These ejected layers will be rich in heavy elements, which are essential for the formation of new stars, planets, and even life. The process of stellar death, including the shedding of these materials, contributes to the enrichment of the interstellar medium, the gas and dust that fill space. This material, once part of the star, will eventually coalesce to form new generations of stars and planetary systems. The heavy elements released during a supernova are also crucial in the creation of the building blocks for life. In a way, the life cycle of a star like Betelgeuse is a microcosm of the greater processes that drive the evolution of the universe itself. The birth and death of stars are fundamental to the ongoing cycle of creation and destruction that defines cosmic history. As one generation of stars dies, it gives birth to the next, and this continuous cycle drives the development of galaxies, planetary systems, and even life. When Betelgeuse goes supernova, the shock waves created by its explosion could trigger the formation of new stars in the surrounding regions. This phenomenon, called triggered star formation, occurs when the shock wave from a supernova compresses nearby gas clouds, causing them to collapse and form new stars. Interestingly, the study of stars like Betelgeuse also provides insight into the potential fate of our own Sunday. While Betelgeuse is far more massive than our Sun, the processes it is undergoing are similar to those our Sun will eventually experience, though on a much longer timescale. Currently a middle-aged star, the Sun will eventually exhaust its hydrogen fuel and expand into a red giant, much like Betelgeuse. Although it will not reach the same size, the fundamental process of fusing heavier elements and shedding outer layers into space will be similar. Understanding the behavior of stars like Betelgeuse gives scientists a glimpse into the future of our own solar system, though that future is still billions of years away. Findings from the James Webb Space Telescope, JWST, have provided astronomers with a more detailed view of Betelgeuse than ever before. JWST's ability to observe in the infrared spectrum allows scientists to see through the thick dust and gas surrounding Betelgeuse, revealing details about its surface and magnetic fields that were previously hidden. This unprecedented level of detail is helping researchers better understand the complex processes that govern the behavior of massive stars and their inevitable destruction. The data gathered by JWST is not only helping us learn more about Betelgeuse itself, but is also contributing to the broader field of stellar evolution. Betelgeuse's potential supernova could have far-reaching consequences. As the explosion sends shock waves through space, it could disrupt nearby celestial objects, altering the orbits of planets and asteroids. While the shock wave will likely not reach Earth, the energy released in the explosion may still have significant effects on the surrounding regions. The radiation emitted during a supernova is powerful enough to impact the chemistry of nearby stars and planets, potentially initiating new cycles of stellar and planetary formation. The end of Betelgeuse serves as a powerful reminder of the transient nature of everything in the universe. Stars, no matter how massive or brilliant, are not eternal. Eventually, they all reach the end of their lives, releasing their energy and matter back into the universe. This process of death and rebirth is a fundamental aspect of the universe's cycle, ensuring that the elements necessary for life continue to be recycled and reused across time and space. Through the study of stars like Betelgeuse, we gain not only a deeper understanding of the universe's past, but also a glimpse into its future. As Betelgeuse continues to evolve, it will eventually reach a critical point where its internal pressures and temperature will no longer be sufficient to sustain nuclear fusion. At that moment, it will collapse inward, triggering a catastrophic explosion. This supernova will mark the final stage of Betelgeuse's life, and the remnants of the star will either become a neutron star or a black hole, depending on its remaining mass. The energy released during this event will be so immense that it will outshine the rest of the galaxy for a brief period, providing a spectacular view for anyone observing the sky at that time. Ultimately, the death of Betelgeuse will provide astronomers with valuable data about the final stages of a star's life and the forces at play during such a dramatic event. Even though we may not witness this cosmic spectacle in our lifetime, the knowledge gained from studying Betelgeuse will continue to shape our understanding of the universe for generations to come.